Ever imagine stepping into a shimmering portal? Some kind of cosmic shortcut that just whisks you across the galaxy like that. Sounds like pure science fiction, right? Well, today, on the deep dive, we're going deep into the world of wormholes.
Wormholes.
Are these theoretical tunnels through spacetime just a figment of our imagination? Or could they really exist?
Yeah, what's captivating about wormholes is that they're not just a product of science fiction. They actually emerge from the equations of Einstein's theory of general relativity,
Oh, heavy.
the same theory that explains gravity, black holes, and the very fabric of our universe.
Okay, so we're talking about real science here, not
Yeah.
just fantasy.
Right.
But there's a question that keeps popping up, especially on Reddit. Just because the math checks out, does that mean wormholes actually exist out there in the vastness of space?
It's a question that gets to the heart of the relationship between theoretical physics and reality. One Redditor put it brilliantly: you can write down the math for pushing on a rope, but in the real world, the rope just buckles. It's inherently unstable. So, could the math for wormholes be describing something that's physically impossible?
That's a great analogy.
Yeah.
And it brings us to the concept of Einstein-Rosen bridges.
Okay.
Now, these are theoretical wormholes that connect a black hole and a white hole. Imagine a black hole as a cosmic vacuum cleaner, sucking in everything that gets too close,
Yeah.
and a white hole as its opposite, spewing out matter and energy.
Exactly. But here's the catch. According to our current understanding of physics, these Einstein-Rosen bridges would be impossible to actually travel through. They'd collapse faster than you could say wormhole.
So even if we could somehow find one of these theoretical bridges, it wouldn't be a very useful shortcut. But the Reddit discussion also delves into another intriguing point. Could our understanding of physics itself be incomplete? General relativity works incredibly well on a large scale, but it seems to break down at the quantum level where things get really weird.
That's right. The laws of physics that govern the universe on a grand scale don't seem to play nicely with the rules that govern the subatomic world.
Right.
This disconnect has led some physicists to speculate that a more complete theory of physics, one that unifies general relativity and quantum mechanics, could reveal something new about wormholes.
This brings us to a fascinating development in the world of quantum physics. A recent experiment by Google that has everyone buzzing. They claim to have created a baby wormhole in a lab using a quantum computer.
The Gets It Fly Science YouTube video does a great job of breaking down this experiment. Basically, researchers used a quantum computer to simulate a wormhole and successfully teleported a particle through it.
Teleportation. Now we're talking. But I imagine teleporting a single particle is a far cry from sending a spaceship through a wormhole.
Absolutely. And there's a lot of debate in the scientific community about whether this experiment truly represents a wormhole or just a clever simulation. Some experts, like quantum computing expert Scott Aronson, are skeptical, comparing it to a wormhole on paper.
So it's not quite the breakthrough some headlines might suggest. But here's where it gets really interesting. The lead researcher, Maria Spiropoulou, believes that this baby wormhole could potentially be scaled up in the future.
It's a bold claim, and only time will tell if it's possible. But even if this experiment doesn't represent a true wormhole, it could still be a crucial step towards understanding how to create and manipulate them.
Okay, so let's say, for the sake of argument, that we figure out how to create a wormhole big enough to travel through.
Okay.
There's still a major problem: stability.
Right.
As Chris Kasak points out in their video, wormholes would be incredibly unstable and likely collapse under their own gravity.
That's where the concept of exotic matter comes in. It's a theoretical substance with negative mass that could potentially counteract gravity and keep a wormhole open. Imagine a substance that, instead of being pulled by gravity, actually pushes it away.
That's pretty mind-bending. But here's the catch. Exotic matter has never been observed. It's purely theoretical at this point, which makes it a huge hurdle for anyone hoping to build a stable wormhole.
That being said, Chris Kasak does offer a glimmer of hope. They suggest that the vacuum of space itself might actually behave like exotic matter.
Whoa.
Quantum fluctuations, tiny bursts of energy that pop in and out of existence, could potentially be harnessed to stabilize a wormhole.
So we need this exotic matter, which might be hiding in plain sight within the fabric of space-time itself. This is getting pretty complex.
It all circles back to the need for a unified theory of physics, one that bridges the gap between general relativity and quantum mechanics. If we can crack the code of quantum gravity, it could unlock the secrets of wormholes and revolutionize our understanding of the universe.
Well, that was a lot to take in. From the mathematical foundations of wormholes to the possibility of harnessing the quantum vacuum, we've covered a lot of ground. But don't worry, we're just getting started. In part 2 of this deep dive, we'll explore the mind-blowing implications of wormholes for space travel and even time travel.
We'll delve into the potential dangers of wormhole travel and grapple with some of the most profound questions about the nature of time and causality. Make sure you stick around.
We'll be right back after a short break. And don't forget to like and subscribe to the deep dive for more award-winning content like this.
Before the break, we were discussing how a unified theory of physics could be the key to unlocking the secrets of wormholes. Now let's shift gears and dive into one of the most mind-boggling implications of wormholes: time travel.
Time travel through wormholes. It's the stuff of science fiction, but could it actually be possible?
It's a question that has fascinated physicists and philosophers for decades, and while the idea might seem far-fetched, it's not entirely ruled out by our current understanding of physics.
So how would time travel through a wormhole actually work?
Let's imagine a wormhole where one end is positioned near a massive object, like a black hole, and the other end is an empty space. Now, because of the intense gravity near the black hole, time would flow more slowly at that end of the wormhole.
Hold on, slower time. How's that even possible?
It's all thanks to Einstein's theory of general relativity, which tells us that gravity can actually warp time. The stronger the gravity, the slower time flows. This phenomenon is called time dilation.
Okay, so if I were to travel through this wormhole from the empty space end to the black hole end, I'd essentially be traveling forward in time, relative to someone who stayed behind.
Precisely. And because time is relative, someone observing you entering the wormhole near the black hole would see you emerge from the other end in the past.
Wow, that's incredibly strange to think about. But wouldn't this kind of time travel create all sorts of paradoxes? Like, what if I went back in time and prevented my own birth?
That's the classic grandfather paradox. And it's one of the main reasons why many physicists are skeptical about the possibility of time travel. If you could change the past, it would create all sorts of logical inconsistencies and potentially unravel the fabric of reality as we know it.
So time travel through wormholes remains a highly speculative idea. But even if it turns out to be impossible, just the fact that it's a theoretical possibility is fascinating. It raises profound questions about the nature of time, causality, and the limits of human knowledge.
It certainly does. Now let's move on to another important question. Even if we could create a stable wormhole, would it be safe to travel through one?
That's a great point. I mean, would you be brave enough to step into a cosmic tunnel that could lead to who knows where?
It's a gamble for sure. Remember what we discussed earlier. Wormholes would involve encountering extreme gravitational forces and potentially navigating unknown regions of spacetime.
And as Kurzgesagt mentioned, even if we could create a wormhole, it would constantly try to close up, almost like a rubber band snapping back into place.
Exactly. And let's not forget about the need for exotic matter to keep the wormhole open. We're not even sure if exotic matter exists, let alone how to control it. A wormhole could be incredibly unstable, fluctuating in size, or even shifting its connection points.
So even if a wormhole were big enough for a spaceship to enter, it might collapse before you could reach the other side. Or you might end up somewhere completely unexpected.
It's a fascinating thought experiment, but the reality is we're nowhere near being able to test these ideas.
Well, this deep dive has definitely given me a whole new perspective on wormholes. They're not just a cool sci-fi concept. They're a window into some of the most profound mysteries of the universe.
And the exploration of these mysteries is ongoing. New discoveries in physics, like the Google quantum experiment, are pushing the boundaries of our understanding and opening up new possibilities.
It's a reminder that we're still at the very beginning of our journey to understand the cosmos. And there's so much more to learn.
Speaking of learning, in part 3 of our deep dive, we'll tackle a question that's been on everyone's mind. If wormholes do exist, what might they look like? Could we even detect them?
That's a great question. Stay tuned. Welcome back to the deep dive. We've been on quite a journey exploring the mind-bending world of wormholes, from their theoretical foundations to the tantalizing possibility of time travel. But let's shift gears now and tackle a question that's been lingering in the back of our minds.
The question of what a wormhole might actually look like.
Yeah.
If we could somehow observe one directly.
Imagine for a moment that wormholes are real and we have the technology to detect them. What would we see? Would it be a swirling vortex or a cosmic doorway or something completely different?
One source gives us a pretty vivid description. According to Kurzgesagt, a wormhole would appear spherical, like a shimmering window into a distant place.
Okay.
Light from the other side would pass through, giving you a glimpse of another part of the universe.
That's a beautiful image, almost like a cosmic portal connecting two distant points in space and time. But wouldn't the intense gravity around a wormhole distort the light passing through it?
Absolutely. The fabric of space-time would be warped, creating some truly strange visual effects.
Okay.
Think of a distant star whose light is bent and magnified by the wormhole's gravity,
Right.
making it appear much brighter and larger than it actually is.
Or maybe even creating multiple images of the same star,
Yeah,
like a cosmic kaleidoscope.
exactly. And the closer you got to the wormhole, the more extreme those distortions would become. It would be a truly surreal experience, defying our everyday understanding of space and time.
Okay, now I'm really starting to get a sense of just how mind-bending these things would be.
Yeah.
But let's bring things back down to Earth for a moment. If wormholes are out there, how could we even detect them? It's not like we can just point a telescope at the sky and say, there's one.
That's a challenge that astronomers are actively grappling with. One possibility is to look for unusual gravitational effects. Remember, a wormhole would have a powerful gravitational field just like a black hole.
So if we observed a star behaving strangely, like orbiting an invisible point in space, that could be a sign of a wormhole lurking nearby.
It's a possibility. The wormhole's gravity could be tugging on the star, causing it to deviate from its expected path. And as Chris Cassatt pointed out, some physicists even think the supermassive black holes at the centers of galaxies could actually be wormholes in disguise.
Now that's a truly mind-blowing idea. It would mean that these cosmic giants, which we thought were just sucking in matter and light, could actually be gateways to other parts of the universe.
Of course, it's just a hypothesis at this point, and it would be incredibly difficult to prove. We'd need to study the behavior of objects near the center of a galaxy in extreme detail to see if there's any evidence of a wormhole's unique gravitational signature.
Well, it sounds like the hunt for wormholes is going to require some serious scientific ingenuity. But wouldn't it be incredible if we actually found one?
It would be a monumental discovery, revolutionizing our understanding of the universe and opening up a whole new realm of possibilities for exploration and perhaps even travel beyond our wildest dreams.
This deep dive has been an incredible journey, full of twists and turns, mind-bending concepts, and tantalizing possibilities. We've explored the science behind wormholes, grappled with their implications for space travel and time travel, and even imagined what it might be like to see one with our own eyes.
And while we've covered a lot of ground, remember, we've only scratched the surface of this fascinating topic.
So if you've been captivated by the mysteries of wormholes, don't stop here. Keep reading, keep researching, and keep that sense of wonder alive. Who knows what incredible discoveries await us in the vast expanse of the cosmos?
And if you enjoyed this deep dive, be sure to like and subscribe so you don't miss our next award-winning episode. Until then, keep those minds expanding.